All right, so the height of we're talking about free falling object for example number 8, and it says find the velocity and position of these when the initial height is 0. And that's all the information they give us. But you guys had an amazing physics teacher. What does the acceleration do to gravity?
9.8.
Okay, so it's just, now didn't I say that the position equation, if you take the derivative, then take the derivative,
Equals acceleration.
it equals
Double
acceleration. So yeah, thank you. S double prime of t is equal to 9.8 meters per second. So we have a constant. And they want us to figure out the velocity and position. So find the velocity and position.
Single prime.
So what we want to do, I guess what we're going to have to do is go backwards, right? So the first thing I need to do is I'm going to transition, and we're going to have to figure out what this is, which is what?
9.8 t.
So this would be 9.8 t
Plus c.
plus c. Thank you very much. All right, and then
Is the first one the position, and then prime is velocity? Correct. Or backwards? Yes. Okay, I'm right.
well now, yeah, the first one is position. So I've got to do s of t. I'm trying to think of an easy way to explain this. All right, so let's focus in on
You add c twice.
this. So let's start with t. What power of t should we have in the top? 2, right? So it should be like t squared. Now to get 9.8 in the front, we had to take this 2 and multiply it by something to get 9.8.
Divide 9.8 by 2.
Which is
4.9.
4.9. Very good. Now if this is a constant, that means what?
It doesn't, it stays the same because it's constant.
It should have been a constant times t, right?
Yeah.
If we took the derivative of it. And we should have a third constant here, maybe. There's a, I mean, it could be 0. I'm going to draw that as a different color because it may be a different thing. Okay?
Right.
So I'm just, these are not the answers, but I'm just trying to wrap my mind around it so I know what to do next. So what we've done is we've got the position and the velocity, kind of. So let's start. It'd be helpful if I knew what c was. All right? So now let's start with s prime. So if I say s prime of t is equal to 9.8 times t plus c. Okay. So if the initial height is 0, the initial position was 0, and it's a free fall, and I think I said that, but this is a free fall.
Yeah.
When t equals 0, what is the initial velocity?
0.
0, right? So I'm holding something like this. The instant I let go, it hasn't started to move yet. So the initial velocity is 0, right?
Yeah.
How do I use that information? That means that these, if we were to plot this, it's kind of like t, comma, velocity, right?
Yep.
So that means, so we could think of this as like the velocity. When t equals 0, v equals 0, right? So that means I would have 0 is equal to 9.8 times 0 plus c. So I'm solving for this first c. I probably shouldn't use this color for this c, because I don't want to confuse you guys. All right, so now if I solve for c, what's c equal?
0.
0. So the first c equals
0.
0. So that means my velocity equation of time is just simply 9.8 t. Okay, check that off the list. Is that right?
Yes, sir.
All right, so now we want to do height, which is the position, which is s double prime. So if I want to think of height as a function of time, I need to remember that this was derived from something that looks like this, 4.9 t squared plus c. I need to solve for c. What do we know?
I thought it was c times t.
There was a possibility. I was just thinking out loud.
Oh, I thought.
Turns out c was 0, so
Okay.
does that make sense?
Yeah.
That's a good question, though. I'm glad you remembered. It shows that you're paying attention. Okay. So what do I know? Well, this is the height. What's the height
0.
when t equals 0?
0.
0. So now for this equation, it would be like t comma h, because height is a function of time. Right? So I'm going to plug in 0, h of t, is equal to 4.9 times 0 squared plus c. What's c equal?
0.
Hmm?
0.
0. So if c equals 0, then my height as a position of time, or as a function of time, should be 4.9 t squared. My velocity as a function of time should be 9.8 t. My acceleration as a function of time should be 9.8. And so this would be meters squared. This would be meters per second. Not meters squared. I wrote the right thing now. Meters per second squared, meters per second, and this would be meters. So we have meters, then we have meters per time, and then we have meters per time per time. So what we did is, this is s of t, s prime of t, and then s double prime of t. But we work backwards. That makes sense? And then if you look at that, it's pretty easy. If I take the derivative of the first line, I get the second line. If I take the derivative of the second line, I get the third line. That's it. Any questions?
Yeah.
All righty.